In the constellation Orion lies a star that has fascinated astronomers for centuries. This star is Betelgeuse, a red giant much larger and more massive than our Sun. However, in recent years, Betelgeuse has shown unusual behavior, dimming significantly and experiencing violent vibrations. These events have led to speculation that this star is on the verge of a supernova. But what if what we're witnessing is actually the beginning of an even more terrifying event? What if Betelgeuse is not about to explode, but to collapse in on itself? Join us on this journey to the shoulder of Orion's warrior to analyze in detail these changes in Betelgeuse and the possible consequences for Earth. Betelgeuse is a star of gigantic proportions, with a size that is approximately 1,000 times larger than our own Sun. While its grandeur is astounding, it also carries with it the fate of the massive stars, a limited lifetime that could trigger a catastrophic supernova explosion. The uncertainty lies in the exact timing of this eventual collapse, making it a cosmic time bomb that remains a mystery to scientists. Only 650 light years away, Betelgeuse has captivated astronomers with its brightness. We stand in awe of its brilliance as we try to unravel the mysteries hidden in its fiery depths. Surprisingly, only 13% of its radiant energy is visible to us. If we could see its full splendor, it would eclipse even Sirius, the brightest stars in our night sky. Imagine a gigantic star with a radius of 1,000 times that of our Sun, extending beyond the asteroid belt and almost touching Jupiter. In this vast realm, Earth, Mars, Mercury, and Venus would be devoured by the irresistible cosmic allure of Betelgeuse. However, the mysteries of Betelgeuse do not end there. Every millennium, the star throws off a solar mass, releasing a magnificent stellar spectacle in the form of a nebula. This nebula, which is 250 times larger than the star itself, envelops a Betelgeuse with an ethereal haze that draws our gaze. Extending its reach to 30 astronomical units, this nebula invites us to witness a cosmic dance of wonders and discovers its deepest secrets. Delving into the heart of Betelgeuse's creation, we find the alchemy of hydrogen fusion, where helium ignites in a cosmic explosion. Eventually, the star's hydrogen field runs out, triggering a celestial metamorphosis, and the star begins to fuse carbon, unleashing a glow that spreads across the cosmos. However, even this grandiose fusion has its limits, and when iron forms from the fusion, a momentaneous transformation occurs. The star's gravitational pull is released due to the absence of energy, triggering an imminent collapse that propels Betelgeuse towards a fate that is both awesome and cataclysmic: a supernova explosion. This colossal celestial entity releases a force equivalent to the energy of 10 billion suns, creating unimaginable power that resonates throughout the cosmos. Over the centuries, the stars undergo a fascinating transformation from the vibrant blue hues of their youth to the fiery reds of their maturity. During the 2nd century BC, Chinese stargazers made an intriguing observation, identifying Betelgeuse by the distinctive red color that set it apart in the celestial tapestry. Eventually, this observation passed to the keen eyes of the Greco-Roman astronomer Ptolemy in the 2nd century AD, who, in his meticulous records, described Betelgeuse as having an orange or reddish appearance, a feature that to this day continues to catch our attention. The consistent coloration of Betelgeuse throughout different civilizations, including medieval Middle East observers, adds even more intrigue to its mysterious nature. The story of Betelgeuse takes an enigmatic turn as we dive into its surprising behavior. In 2019, the star puzzled scientists by suddenly dimming in brightness. It was thought that a large cloud of dust shed from the star's surface blocked our view of it, but there is still no clear explanation for its origin. Some scientists speculate that a sizable object, such as a planet, may have disturbed the star's surface or even been absorbed by it. In recent months, Betelgeuse has shown an increase in brightness close to 50% of its average brightness, which is unexpected, as normally stars tend to become dimmer as they age. Scientists are unsure of the cause behind this sudden increase in brightness, although they know that stars can experience brightness changes for a variety of reasons. For example, some stars go through cycles of bright and dim phases. Star Mira is known as the Wonder Star because it changes its brightness, expanding and contracting on a regular basis, which affects the amount of light that it emits. This phenomenon is common in many stars, including the star Eagle and 30 other stars that can be observed in the night sky without a telescope. In the deep core of Betelgeuse, a seismic shift was taking place, where the ejection of fiery material hurled into space created an ethereal dust cloud of magnificent proportions. A veil of celestial dust covered a significant portion of Betelgeuse's radiant light, transforming it from a glowing beacon to a dim luminary in the night sky. Its brightness declined to unimaginable levels, dropping from being one of the 10 brightest stars to being among the 20 brightest. In recent months, Betelgeuse has defied all expectations and baffled scientists around the world with its extraordinary behavior. Theories abound that attempt to unravel the enigma behind these dramatic fluctuations. Some speculate that massive sunspot or dust clouds could be responsible for these changes, while others ponder the possibility of coincident cycles. The research has exposed an incredible notion. The supernova explosion has already occurred. Yes, you heard right. Although previous estimates projected that your supernova event could occur hundreds of thousands of years from now, there is now evidence to suggest a different story. Some scientists believe that a supernova is actually already occurred in our galaxy centuries ago, known as Kepler's supernova, which graces the heavens with its magnificence. Researchers have developed a model that suggests Betelgeuse is in a late stage of carbon burning, indicating that it could be on the verge of a magnificent explosion, making it a strong candidate for the next supernova event in our Milky Way galaxy. As a grand finale in the cosmic symphony, Betelgeuse stands out as a contender for the next supernova within our beloved Milky Way. However, understanding Betelgeuse is like solving a puzzle due to conflicting observations. It has experienced massive ejections of material in a subsequent recovery, suggesting a mass ejection event, though not on the scale of our star, the Sun. Herein lies the twist. Supernovae are real phenomena, and we witnessed one in a satellite galaxy of the Milky Way in 1987. Although our estimates of the Betelgeuse explosion may be uncertain, there is no time to plan a vacation around it. The challenge lies in the difficulty of observing a Betelgeuse. Scientists have studied this star for centuries and have observed changes in its brightness, suggesting that it is aging and could go supernova in the near future. However, there is insufficient evidence to say with certainty when this will occur. A supernova is an extremely bright explosion that occurs when a star reaches the end of its life. Although harmless to life on Earth and safe to observe with the naked eye from our planet, the brightness of a supernova depends on the size of the exploding star. Since Betelgeuse is a very large star, its supernova will be extremely bright, comparable to a crescent moon and visible even during the day. Get ready for a cosmic disaster on a scale never seen before. Betelgeuse, the red supergiant, is sending terrifying signals across space. Astronomers have discovered something profound about this huge object using the James Webb Space Telescope. Brian Cox has issued a very serious warning. The question that keeps coming up is, are we about to witness a supernova explosion so big that it will change the night sky forever? In the vastness of the universe, stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of both astronomers and the general public. It is Betelgeuse, a red supergiant star that stands out in the cosmic constellation of Orion. A large and very old star, its reddish color and changing brightness have long been fascinating. But recently, events have made people even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a major event in its history. But what could these changes in Betelgeuse mean? Are we seeing the beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant, 900 times larger than our Sun, something difficult for humans to comprehend. Imagine a star so large that if it were to replace our Sun, its surface would reach beyond the orbit of Mars and envelop Mercury, Venus, Earth, and Mars. This enormous size not only shows how impressive Betelgeuse physically is, but also at what stage of its life cycle it is right now as a red supergiant. Betelgeuse is nearing the end of its life, expanding and cooling in this phase that comes after converting hydrogen to helium in its core. However, the star is believed to be between 8 and 8.5 million years old. It's been changing dramatically over millions of years to become the red giant we see today. It is now in its final stage as a red supergiant. Supergiant stars like Betelgeuse undergo significant changes throughout their lives due to the constant pressures of nuclear fusion and gravity. What makes this stage of Betelgeuse unique is its reddish color. Its red hue is due to the fact that its surface is cooler than the other stars like our Sun. While the surface of the Sun has a temperature of about 5,500 Kelvin, the surface of Betelgeuse is about 300,500 Kelvin. Because of this lower temperature, Betelgeuse emits light at a wavelength that make it appear red. But this color is not just an appearance, it tells us something about the physical state of the star and the process occurring in its huge gaseous volume. The color of Betelgeuse has changed over time. During the Roman and Chinese eras, Betelgeuse was said to be yellowed about 2,000 years ago. In the 9th century, Arab astronomers were the first to claim that it was red. This change in color throughout human and scientific history has also shown how the star has evolved over time. Another interesting thing about Betelgeuse is that its brightness varies over time. It is a variable star, which means that its brightness rises and falls regularly. This variation has fascinated scientists and sky watchers for hundreds of years. Betelgeuse goes through a brightness cycle of 400 days and a longer cycle lasting 5 years. As early as 1836, Sir John Herschel wrote about these cycles, and Aboriginal stories may go back even further. However, what really makes Betelgeuse mysterious is not only how its brightness changes, but also how irregular it can be. Unlike many stars that dim and brighten in predictable ways, Betelgeuse sometimes deviates from this pattern, suggesting complicated and less understood processes with its enormous structure. Recently, astronomers and stargazers around the world were surprised to see Betelgeuse's appearance change dramatically and unexpectedly. This is known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky and a prominent feature of the constellation Orion, began to dim in a mysterious way. The star was fading at a rate of 0.01 magnitude per day on average. By February 2020, Betelgeuse was at its faintest. Normally visible to the naked eye, even in places with lots of light pollution, it had become much fainter, and onlookers could tell the difference. However, the paradox of time complicates observing Betelgeuse, as it takes a long time for the star's light to reach us. When we look at Betelgeuse, we see it as it was almost 654 years ago, because it is about 654 light years away. This time lag makes it difficult to predict and monitor rapid changes in its behavior. The Betelgeuse dimming event was a reminder of how complicated it is to observe the night sky in real time and how little we know about this big, strange world of space and time. Andrea Dupree, Deputy Director of the Harvard Smithsonian Center for Astrophysicists, and her team took a close look at Betelgeuse's dramatic events as part of a 3-year study to track changes in the star's outer atmosphere using Hubble. These observations provided new insights into how a variable star, like Betelgeuse, works. Variable stars regularly expand and contract, causing changes in their brightness. The researchers were able to observe the star's surface layers, heated in part by swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Studies of Hubble's spectra taken at different times in 2019 and 2020 helped determine how fast things were moving in Betelgeuse's upper atmosphere. They found that material was moving from the star's surface into its atmosphere at about 200,000 miles per hour, eventually reaching millions of miles away from Betelgeuse. Now, this movement of material contributed to the formation of a dust cloud that made the star appear less bright for 3 months. Dupree and his team thought that about twice as much material from Betelgeuse's southern hemisphere had been ejected. This mass loss was remarkable because it occurred at a much faster rate than expected. The astronomers wondered whether this event might be a sign of an upcoming supernova explosion, given how large the mass release was and how faint the star became. At 654 light-years from Earth, Betelgeuse's behavior remains a mystery. Such an explosion would be visible from Earth and would give people a rare chance to see a supernova up close. But the question remains, is this a sign that a supernova is about to occur? Or is it simply a one-time event in the long and complicated life of Betelgeuse? As we contemplate the Sun, we are aware of its enormous power and the energy it emanates throughout our solar system. It is hard to imagine anything capable of surpassing our Sun, yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Betelgeuse, the red supergiant, defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. The star is an enigma to scientists who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Join us on this tour as we dwell into the constellation Orion with the James Webb Telescope and explore how its arrival could change our understanding of Betelgeuse and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Although many people are unaware of this fact, it is possible to spot Betelgeuse in the night sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellation Orion and Canis Major to see this dazzling star in all its splendor. There you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. This star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at the star, you will have noticed that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence, since Betelgeuse, as the star is called, is no ordinary star. Although to us it may appear just to be one more in the vast firmament, it is located at a distance of more than 640 light-years from us. At first glance, this figure may not seem impressive, but in reality it represents an enormous distance. To illustrate this magnitude, let's imagine that we could travel at the speed of light, which, unfortunately, is not possible. Even in that hypothetical scenario, it would take us more than 640 years to reach Betelgeuse. If we wanted to undertake such a journey into a spacecraft, even using our most advanced technologies, it would take us more than 12 billion years to reach it. This figure far exceeds the entire history of human civilization on Earth. However, the scarcity of light from Betelgeuse is not only due to the distance that separates us from it. Betelgeuse is what is known as a pulsating red supergiant, which means that it's an ancient massive star that undergoes expansions and contractions. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods, ranging from tens to hundreds of days. The amazing thing is that Betelgeuse can oscillate in brightness over a wide range. It can range from near magnitude 0.5 to reach 0 magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest being 2,335 days at times. At certain times, Betelgeuse can become quite faint, which is called V-band magnitude. In February 2021, it was reported to present its lowest V-band magnitude in a long time, reaching a magnitude of plus 1,614. Although it's relatively bright, it is definitely fainter than how we usually observe Betelgeuse. However, brightness is not the only outstanding feature of the star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface, which has a temperature of about 3,500 Kelvin. This temperature is much lower than the surface of our Sun, which reaches 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. That is why, despite being one of the largest stars we know, it appears much dimmer. Betelgeuse is like that giant that is satisfied with a low profile and doesn't need to show off its size to feel important. However, don't be fooled by her appearance. Betelgeuse is a supergiant star that is about 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies. Over the centuries, it has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Ptolemy. His name in Arabic means Orion's armpit. Although not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter Submillimeter Array, or acronym ALMA, L-A-M-A, a state-of-the-art observatory located in Chile. ALMA, or ALMA, has provided high-resolution images of the surface of Betelgeuse, revealing details about its structure and behavior. One of the most remarkable discoveries made by LAMA, or ALMA, is the presence of an extensive plume of gas extending from the surface of the star. This plume is believed to be caused by pulsations from Betelgeuse. These pulsations, which can be explained by a process called convection, involve the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also been obtained, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict how it might behave in the future. In addition, Betelgeuse's surface is marked by dark spots, also known as star spots or magnetic spots. These areas on the star's surface exhibit particularly strong magnetic intensity. These regions, known as star spots, are areas on the surface of Betelgeuse that are cooler. This is because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. As a result, the spots appear darker compared to the rest of the surface. Betelgeuse's magnetic field is believed to be thousands of times stronger than that of the Sun. This intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, describing regions of intense magnetic activity that are visible as star spots. It is important to mention that the presence of star spots is not unique to Betelgeuse, as they are also observed in other stars, including our own Sun. The star spots in Betelgeuse are very especially interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is significantly larger and more numerous than the sunspots on the Sun. These star spots can affect the overall brightness of the stars and cause variations. As the spots move in and out of view, Betelgeuse's brightness can fluctuate. This is because the spots, being cooler, emit less light than the surrounding gas, which contributes to changes in the observed brightness of the star. In the case of Betelgeuse, pulsations of the star also contribute to the brightness variations. As the star expands and contracts, star spots move in and out of view, further amplifying the star's observed brightness. The surprising thing is that Betelgeuse is not as unique as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. One of Betelgeuse's cosmic cousins is Antares, a red supergiant located in the constellation Scorpius. Antares is also a variable star, meaning that it undergoes changes in brightness over time, just like Betelgeuse. In addition, Antares has a mass approximately 12 times that of the Sun and a radius that is 700 times that of the Sun. So, it's safe to say that Antares is no slouch in terms of size. Now, what do you think? Do you think Betelgeuse has already exploded and it's just a matter of time before we see it in our skies? Let us know in the comments box. If you liked the video, like and subscribe to the channel. Thank you so much for watching. See you soon.